In physics, we've got basically two types of numbers, vectors and scalars.
Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
Where a vector, something that has direction. And so that's something like a force, an acceleration, velocity, and even a displacement. All have directions. They all go a certain way. They have a certain amount in a certain direction. While scalars, on the other hand, are something that do not have direction. For example, mass. You just have mass. You don't have mass in a certain direction. Same thing with time. It's very hard to go left in time. Time only goes, we call it forward, but just time exists. It persists. Volume. You just have volume. You don't have it in a certain direction. You just have an amount. And so a scalar just has an amount, while a vector has both an amount and a direction. What can we do with these vectors? Well, it's really important to understand that as long as you keep the length of a vector the same and its direction the same, then you can put them in pretty much any order and get the same thing. So let's say I've got this vector here. It's off at some angle. We're not going to worry about the angle right now. It's off this way. It's made up of two components, or two pieces. A horizontal piece and a vertical piece properly. That looks good. Okay. So if I pull up on this object, let's say it's a box, and somebody else pulls this way, and this is my relative force, and that's their relative force, we should get a resultant, that's the result of two vectors, moving in this direction. So the box should kind of go that direction. Well, what can we do with that? Let's say if I put this over here, we go over and then up, we get to the same place. If I move it back, then use this one. If we go up and over, we end up in the same place. So it doesn't matter the order as long as we have these two. So solving this for the vertical piece and for the horizontal piece, it's really not that difficult, but it's a little confusing that way. But if we make a nice right triangle out of it, now if we know this angle and the resultant, the length of this, we can easily find the vertical piece and the horizontal piece just using some basic trigonometry. Likewise, if we know this horizontal piece and that vertical piece, again, using trig, we can figure out the angle and the length of this hypotenuse. Let's first look at this idea about these vectors. As long as you keep the length the same and the direction the same, it doesn't matter which order you put them in. So let's look at this. We're going to start down here at this orange dot. And I've got several vectors that I've drawn. Most of them aren't exactly vertical or horizontal, but as long as we keep them the same, it shouldn't matter too much. So let's say I'm going to start off by putting all the reds, starting off at my spots here, and putting them end to end. When you add vectors, you always go from the head of one vector to the tail of the next vector. So it's always head to tail. So I put them all connected there. Then let's say let's go over to the right. So I want to connect these here. Grab that one, move it up. Let's go down. That way we won't have to backtrack over. Almost forgot this one. Put that there. And then let's use the blues now. There, and then this one here. And we end up pretty much at that black dot that I marked there. What if we put them together in a different order? This one I kept all the verticals of the same direction, all the horizontals the same direction together. What if I mix and match a little bit? So let's say I want to start off with that blue one. And then let's say I don't want that red. Let's say I want this red. And now I'll take this one here. And oh, let's take the small one, keep it on the screen. There, and then let's see, oh, let's take this big long blue one. Put it there. Okay, and now this red one here. And this green over here. And then, oh, let's do this one back down this way. And remember, we got to go tail to head, so, or head to tail, so I need to put that one there. And look, we're back at that black dot again. But it doesn't matter which order I put these in, I'm always going to end up starting from that one spot and ending up at that black dot. It doesn't matter which order I put these in. So we can slide vectors around as much as we want, as long as we keep the length the same and the direction the same, to figure out whatever problem we have consisting of vectors. So just remember that the resultant is the sum of two or more vectors. It's basically the result. And I always prefer making the right angle to the x-axis. So whenever I make my triangle, let's say again, this is my vector. I want to try to drop a perpendicular down to the x-axis. Make that a little bit longer. To make my vector this way. Again, nice right angle there if I drew it properly. Sine will always find you the vertical part. Cosine will always find the horizontal part. If we know these two sides, Pythagorean theorem will get you the resultant, and tangent will get you the angle.